series, what we'll be talking about, is how to use the inbuilt libraries of linear regression. I must say that it's not inbuilt, but all the tricky part of finding the differentiation and finding the gradients and all that stuff will be taken care of by the libraries. But before this video, I must insist that you must have a quick look at the first part, because in the first video we have done all that thing from scratch. Okay, we have formed the mathematical equations and we have done all that stuff there. In this part, we will try to make it a little more simpler and a little more easy to understand. Okay, so here we go. Okay, so let's say that. Just a minute, setting everything up. Okay. The libraries that we have used earlier, import torch and import numpy as np. This will be two things that we will be needing. Apart from this, we will also need a few more libraries. Okay, so I'll just import them. So it's import neural network. So it's torch.nn as nn. There you go. Let it load. And let's say that inputs. So what I'm thinking is, in the previous example, what we chose as the input, so we will try to make it somewhat other way similar, so that just a minute. I don't know. Yeah, now it will be much more visible to you all. Okay. So why is it lagging? There you go. So taking care of the inputs, I'm just taking the inputs as we chose in the previous video. They will be same. Nothing will change. Okay, so these are the inputs that we are choosing. Input will be, as I mentioned in the previous video as well, there are 3 dimensions. Like the matrix is of 3 columns and multiple rows. So if we print this, I think you will get an idea. Just a minute. If I do, why is it lagging? If I do this, these are the inputs that we have. So basically, these are the 73 stands for temperature, 67 stands for rainfall, and 43 stands for humidity. And this is the input data set that we have. It might repeat because I have just copied paste the inputs. So let's say 73, 67, and 43. So you might have, yeah, here you go. Okay, so they will be repeating. It's okay though. It will be beneficial for our model. So these are the inputs that we have. And for targets, what we have is columns, because these are number of apples and oranges. So 56 means apples, 70 means oranges. Similarly, 81 means apple, 101 means oranges, 119 means apple, 133 means oranges, and so on. So basically what I'm trying to say is that if that conditions is such that there is a 73 units of temperature, if there is 67 units of rainfall and 43 units of humidity, then we will have 56 apples and 70 oranges, and so on with the different climatic conditions. In our first part, we use the minimum square error to, like, we initially use the random weights, and then we somewhat predicted the accurate weight through minimum square error as our optimizer. So in this also, we will use the same logic, but this time using inbuilt libraries. So it will be much more simpler. Okay. There you go. Okay, before that, 2 more things that you need to understand is, one is called tensor data and second one is called as data loader, sorry. Okay, so in the tensor data set, why we use this is if we want to slice the data set. Okay, because it might be like in pandas, what we used to do is that we slice the data set. That is, we only take that elements that we need. So in TensorFlow also, in Pytorch, we have that called as a tensor data set. So here we go. Here's how you import this torch.utils.data. I'm referencing one more notebook with me because this library is also pretty new to me. That's why, to avoid syntactical error, I'm using one another notebook with me. So now if you want to convert the inputs and the targets that we have and you want to convert them into tensor data set, so what we can do is train.ds is tensor data set, and you can write the inputs that you have and you can write the targets that you have. So if I'm printing, let's say that train ds, and if I want to print only the first entry, So I'm just writing 1 and I'll go. What it will showcase me is that my input is this, then my output will be this. So that's how you can use this tensor data set. It will be very useful for mapping as well as slicing. Okay, this is the one thing. Now, if you know that, if you have somewhat idea of deep learning, then you know that, whenever we are training, it's not like everything is trained once. The whole process is divided into batches. We have batch. Okay, so that's why we use data loader. Data loader is used for a similar purpose. So if we have inputs as this data, then what I'm trying is there will be batches of five entries each. So our model will learn. So if we are iterating through 10 epochs, okay, if we have 10 epochs and we have divided our whole data set into 5 batches, in every batch it will learn. So it will be like 5 batches and we have, let's say, 10 entries. And if you have 5 batches, that means there will be 2 batches. Like in one batch there will be 5 entries. Okay, and now we have 10 entries, so we have 2 batches, and we are running this for 100 epochs. So basically it will be 2 into 100, that's 200 times it will learn. Okay, so I know that that's the, it will go on, like it will sound very complex, but trust me, it's really not. It's very simple to understand. Just rewind the video and try to grasp it one more time. Okay, so whole and short, we are converting them into batches. So how we do that? So you have, from similar way that, torch dot utils dot data import data loader, there you go. And here you can convert them into batches. So I'm just executing this, and what's the batch size that you want? So let's say that I want a batch size of 5. So batch size is 5 and train DL. So here you need to specify, that if you want to shuffle the data and how many times you want to, like how much batch size do you want? So data loader, now train DS. Now train DS stands for, as you guessed it right, that we did initially, we mapped it from the inputs and outputs. At the same time we were able to slice that. So train DS stands for this. So we will use that inputs in data loader. At the same time, what batch size do we want? So batch size, and then we can write that shuffle is equal to true. Shuffle stands for basically that when we have entries in the similar order, like here, it will shuffle the entries so that it's not able to recognize a fixed pattern and leave the rest of them. Okay, so it will shuffle this so that it has taste of every type of entries. Okay, if that makes clear, if that is clear to you. Okay, so there you go. So train DL is ready. So now what we want? Now what we want is that to break the inputs and outputs indifferently. Okay, so for doing that we have for xb yb in DL. So I'm just printing one of the entries for you. So print xy yb and break. So it will separate out the inputs and outputs, and that we want as well, because these are the inputs and this will be the outputs. So we have separated out so that we can use it individually in the minimum square error, where we will use this and our matrix, which is having the random weights, to generate a predicted matrix, and we will compare that predicted matrix with what we have in the YB. Oh, that's a long way to go. Okay, now what? So now I don't have my previous notebook, but in the video you can see that we have created one matrix which was having the dimensions of 3 cross 2 and which was having the random entries, that were the weights. Okay, and we were also creating one more matrix that was having the constants, and then we were multiplying the inputs with the weight matrix and adding the constants to get the predicted matrix, and then we were comparing that predicted matrix with the target that we had. Okay, we were all doing that from scratch, but in this in Torch we have the function for it as well. So what we'll be using is, in the first we imported that function, if you remember, import torch.nn as nn. So that's what we will be using now. Okay, model is equal to nn dot linear 3 cross 2. So this will basically in how many inputs that you have and how much output do you want. If you want to understand the logic that why I did this, please refer the first video. I'll just explain you in brief of what it is. So let's say that you have only one entry of 87, 134, and 58. The size is 1 cross 3. Okay, there is one row, there are 3 columns. And then we want something plus something that will give the answer as we have 1 cross 2, because we want the answer in one row and 2 columns. So here we have star, because yes, now it's fine. So what we want here, we want here something that's basically that's 1 cross 3, and we want this as 3 cross, just a minute, I'm just deleting this. Yes, we want something as 3 cross something, so that it's multiplicable as this column and this row should match. So that's why we have here, where did it go? We have here 3. Okay, and now we have here 2. Now why? Because whatever answer we will get, that will be basically, just a minute, here we have 3 and here we will have 2, so that we will get answer as 1 cross 2 plus it will be 1 cross, because you can only add the element if they are of same dimensions. So 1 cross 2. So let's take this is the entry 87, 134, 58. If I'm multiplying it with the 3 cross 2 matrix, so that will be 1 for apples and 1 for oranges, and we will get 1 cross 2 matrix. So we will add that. This is nothing but weights, and if we add this, we will get our predicted matrix. You don't need to understand all this. It's only for those who are really interested in the maths behind this. But just remember that if you are using nn.linear, these are the number of entries, like the number of inputs that you have. So we have temperature, we have humidity, we have rainfall. This is 3, and 2 means how many outputs that you have. In this case, we have 2 outputs, that is apples and oranges. Okay, don't go in the maths, it's complex. Okay, there you go. Now we want to see what it does. Just print model dot weight print bias. Bias is nothing but constant. There you go. This is the random entries. This will be random entries. So if you want to see how it has performed in our inputs, you can do it also. Just a minute. This is before any processing. Okay, this is just raw entries. It might be possible that they match. It might be possible they do not match. We don't even care. Print prediction. This is what our model. This is what our model predicted. I'll just write 1 because I don't want every entry. Okay, this is what our model predicted, and what's the answer? So for the inputs, targets, and this is what our output is. Okay, it predicted number of apples right, somewhat right, but the number of oranges were minus 61, while our answer was 70. It's completely wrong. And by luck, this matched. Otherwise, I had no hopes that this will match as well, because we have not used any optimizer yet. So let's try some optimizer. Before that, just to keep a track, if you want, we can get the loss function of our initial model, so that we can compare it with what we have after we have trained the model. So to get the loss function, that we use the minimum square error function that we made in our earlier video. In this part, we don't have to make anything. We have already inbuilt all the things. So how to do that? So we can use import torch.nn functional sf, and you can calculate that using loss is equal to, okay, f dot MSC stands for minimum square error, and loss is fn model and targets. Okay, so why I'm doing this? This is okay. This was very simple. Just grasp with me. Okay, here is the variable object that we created out of this class, MSC loss. Now what is there in MSC loss is exactly what we had in our previous video, where it took 2 inputs matrices as the inputs, and it will return a value which will be nothing but the sum of squares, the difference of squares of every element, and summation of this, and divide by number of elements. So it's nothing but average of difference of squares. So these are the 2 metrics that we have input, like we have taken as input. One is the model inputs. That means our weights matrix into inputs matrix plus bias matrix, and this will be the target. So, and I'll return the value. So if I do print loss, you have the initial loss with you. It's it's very bad, okay, but we will gradually improve on as we move further. So okay, so we will use the stochastic gradient method for optimizing it. So how do we do that? So here's how we can import this. First of all, this is also new to me, that's why I have to refer it. Just a minute. Yeah, opt stochastic gradient descent, and you can pass on with the model parameters, that means the inputs, and how much value you want to, like, if effect, how much impact do you want to make. I'll be using the similar entries that I used in my previous video, 1e minus 5. It's a very minor, but it will have a drastic impact. There you go. Okay, now comes the main part of iterating it through various epochs so that we can see the answer. Let's define a function for that. What it will take as inputs, we will take number of epochs, we will take what's our model, we will take the loss function. I'll explain you, okay, I'm explaining you everything. Let me just type it down, opt, and we have TNDL. Okay, so what is number of epochs? Number of epochs basically means that how many times you want your model to run. Okay, that's what number of epochs is. Okay, so what is model? Model basically means that the function that we have created for multiplying the inputs with the weights and plus the constants. Okay, so just to give you a brief what we have, this is what our models is, and this is the loss function. So why we use loss function? Loss function is basically used for taking the two matrices as inputs, finding the difference of squares, taking the average, and returning the loss function. What is OPT? OPT stands for optimizer. So when the loss function has written the value, the OPT will do the complex part of finding the slope and to see the slope is in the positive direction and negative direction. If it's in positive direction, and you know that our inputs are, if they increase the value, then loss function will increase. So it will decrease the inputs, and if the slope is in the negative direction, it will increase the value. And we have train DL. Train DL is nothing but the set of inputs. Okay, so if you want to, just a minute, for I in range of epoch, and here are the inputs, here are the outputs in, there you go. Now this will generate a random entries, of the weights and the bias, and we will use the loss function to feed in the XB spread. That means that what our model has predicted yet, it will use to calculate the loss function. Okay, I hope you have got it till now, but just to give you a brief. So in the train DL, it's basically our data set. XD is the inputs, YD is the output. So okay, just a minute, let me take it, rename as XB. Okay, there you go. Okay, so it's model XB. That means that it will create a random matrix of weights and a constants, and that will be stored in the pred. So pred will be nothing but inputs into weights plus constants, and that will be completely random. So if you want to know that how wrong it is, okay, no, not how right, but how wrong it is, we will use the loss function. So loss function, what will it do is basically take the two matrices as the input. It will individually find the differences between every element. Let's say W11 and pred11 minus YB11 whole square. And similarly, it will do for the all metrics. It will find the summation and it will divide it with the number of elements that it has. That's how we calculate the loss function. Now it will do, if I do like loss dot backwards, that means it will find the slope. If I do OPT, now there is a function to do this, to call this. It's called opt.step. Opt.step, what it will do is that it will take in consideration of the loss. So what it will do is use the model parameters. It will find the difference, like it will find the derivative of loss with respect to every individual element of input, and it will see that if the slope is in the positive direction, it will decrease the element, and if the slope is in the negative direction, it will increase the element with the factor of 1 e power minus 5. After everything is done, you have to reinitialize the whole to 0, so that in every epoch it gets a fresh start. And if you want to see the output, what we can do is that I'm just copying this. Like if you want to see the improvement, we can use this. So in every 10 epochs, we can see that how much improvement we have made in our model. Okay, so I think this function is ready. It's just I'll be calling it in the next function. So it's just fit. I'll be calling it for 100 epochs. You have model, you have your loss function ready, and OPT, and I have my train. Okay, just a minute. It's num epoch. Okay, just a minute. It's not epoch, it's no, sorry. It's I. Where another thing. Okay, it's I. Num epochs. It's num epoch. So there you go. We started from a loss function of 210, and after it has like if it has iterated through 100 epochs, we got the answer of 26, and that's really very nice. But one thing that you might have observed is that we have 10, 10, 10. Similarly, we have 20, 20, 20. Similarly, we have 30, 30, 30. Why is that? If we are only iterating through 100 epochs, why we have something that's in the range of 3? So that's because we have used train DL. As I just mentioned earlier as well, that we have divided our whole input into batches. So we have divided 5, like we have each batch is of 5 element, and there might be 15 elements in inputs, because so there will be 15 elements over here, and that's why every batch has 5 elements. There are 3 batches that are formed, and that's the only reason that it has iterated 3 times in a single epoch. That means it's learning a lot. Okay, so now if we want to see that how much it has learned, so what we can do is spread model, and you can pass on the inputs that you have. You can do that. There you go. Okay, I need to print. It will be very close to what we have in the target now. I'll be just printing the first element, so that you might be like it might be easier for you to understand this. Okay, so this is the thing that our model predicted, and let's see what the answer is. There you go. Okay, just a minute. It's targets. Yeah. So this is what the answer is, 56. Our model predicted 58 point something, very close. And similarly, your answer was 70. Our model predicted 71, a very close prediction. So that's it. If you want to use it using the inbuilt function, you have this. And if you want to create your own algorithm from scratch, you have the first video. So I hope you like this. Thank you so much for watching this. Have a great day. Bye bye.